So we're gonna begin. So remember from the previous video I talked why we have to know the arithmetic and how can we know what to times our parent function by. So if we have f of x equals x squared, we can get the points for this easily. So negative 1, 1, 0, 1, 0, 0. Because we plug in a negative 1, we get a 1. Plug in a 0, we get a 0. We plug in a 1, we get a 1. It's good to memorize them, but it's not that difficult. It's just think of inputs and outputs. So I'm going to show you an introduction to all the different transformations you're going to see. So if we have something like f of x equals negative x squared, the reflections are very subtle, so you have to make sure you understand. When it's on the outside right here, on the outside of the x, that means it's going to be changing the y values. And since this is a negative on outside of the y right here, we can realize that we just times all of our y values by negative 1. So our x values stay the same, but where our parent y values, where we change them, so it becomes negative 1, 0, negative 1. So compared to the original graph of x squared, looks like this, right? Negative 1, negative 1, 0. This is our graph of negative x squared. See? You could plug in numbers to this, but I think it's easier to just realize where it's at times, and it's easier. You can graph points faster. So I'm going to go when I go deeper into the video, I'm going to show something called vertex form. And that's the form you're going to see these in most of the time, but I'll make a different video on how to get to that. But it's just a few patterns you have to realize. So if we have something like another example, f of x equals 2x squared, right away, we know it's on the outside of the x, or actually, this is a rule I want you guys to remember. So if it's not in vertex form, vertex form is like this: f of x equals ax minus h squared plus k. The squared tells us it's a quadratic. And there's missing a b. If it's inside the parentheses over here, okay, and it's on the x, that means it's gonna this is timesing the x. It's gonna reflect all the x values. If it's on the a, it's gonna be timesing on all the y values. So how can I give an example of this? So if I have something like f of x equals 2x minus 3 squared, okay. It's not the outside of the parentheses, so this is our b, so we need to apply our points. I talked about the horizontal shifts. So when you have something, this h right here, this is our addition. Remember I talked about addition and subtraction. The k's and the h's, if you recall, the k's and the h's shift right or left. They're adding. The only ones that do the timesing are the b's and the a's, okay? So something gets to remember. So our b here is 2 and our h is 3. So whenever you see on the horizontal transformation, it's always the opposite. If you have for example, you have f of x equals x minus 3 squared, all you do is you get your parent function graphs, the points, okay, and you add 3 to all your x values. Okay, I know it says minus, but it's the opposite. You add 3, okay? So I like to do it like this. It's not times, it's showing addition. We get 2, 3, 4. Our y values stay unchanged. So this is how our graph is going to look like. So at 2, we're at 1. At 3, we're at 0. And 4, we're at 1. This is how the graph looks like. Originally, we were right here. Remember, we were at negative 1, 1, 0, 0, 1, 1. So see how it moved? That's how it shifts. This is x squared, and this is this function in particular. So if we go back, so now this is the basic introduction to the horizontal shifts. So remember, horizontal shifts is always the opposite. So if we had x plus 3 squared, what we're going to do, we're going to subtract 3 from all of our parent function points. So we have this, we have -1, 1, 0, 0, 1, 1. So we're going to subtract 3. So it's be -4, -3, and 1, -2. So it's going to be 1, 0, 1. Because again, there's nothing else. Only ones that apply to changing our y's are our k's and our a's. The ones that apply to our x's are our b and our h. Okay, here, do we have a b? No, it's just 1, so it doesn't change. Do we have a k? No. Do we have an a right here? It's 1. But we do have an h, so that's what we have to do. So look at the graph now. It's going to be -4, 1, -3, 0, and -2, 1. This is how the graph looks like. See how the difference? This is x plus 3 squared. Okay, so let's try another one. Let's try this one. So how can we do this graph? Equals x minus 3 squared plus 2. So this is our k. Our k is called our vertical shift. I told you about in the other video. So this means this is exactly the same idea as the horizontal shift as the h, but in this case it's not the opposite. What we see is what we see. So again, same procedure. Let's get our x squared points, our parent, because this tells us a square, so we can start off with the squared. So let's get our -1, 0, 1. These are the best points. Always make sure your 0 is where you start. Make sure it's in the middle, because that's where, because the parabola is like a curve, so it needs a middle. Because the axis is line of symmetry, but that's another topic for another time. So we're gonna need this is for x squared, so this is gonna be 1, 0, 1. So what we're gonna do, we're gonna add 3 to our, because we have an h, and we're going to add 2, because when you see something like this, right away think I'm gonna add 2 to the y. Okay, so always when you look at graphing something with transformations, always realize, do I have an a, do I have a b, do I have an h, do I have a k? Here we have an h. This is our h, this is our k, and h and k are always adding or subtracting. Okay, make sure that h is always the opposite sign. You see x minus 3 squared, you're going to add 3 to all your x values. So this is what our graph is going to look like. This is basic math. It's going to be 2, 3, and 4, and now our y values are going to change. They're going to become 2 and 3. So this is what our graph is going to look like. So it's going to become 3, 2, and 3. You see how before our graph looked like this? You see how it moved to the right and it shifted up? So that's something you have to realize. Let's try another one, just for some fun. So we did one with the h, one with the k. Let's do another one with the h, so you make sure. So let's do f of x equals x plus 2 squared. Okay, let's look at this. Do we have an a? No, it's 1. Do we have a k? No, it's 0. It's always plus 0. There's a 1 right here, so we don't have an a. Do we have a b? Yes, it's 1, so does it affect? Do we have an h? Yes, we're being shifted to the left. So that means we're going to subtract all of our parent x values. So let's get our f of x equals x squared. Let's get our parent function graph, because again, I told you there's this square term, so that means that it's a quadratic. So let's get our -1, 0, 1. So make sure you memorize these points, and we're going to subtract 2 to all our y value, to our x value. Sorry, because remember it's the opposite when it's a horizontal transformation, which this is, which h is. So we're going to do that. -2 minus 1 is -3. -2 minus 0 is -2, and -2 minus 1 is -1, and our y values stay unchanged. Make sure what I'm suggesting here is this is not a -2 times. It's actually it's -1 minus 2. So that's just how I do it, but this is a horizontal transformation, and it's the h specifically, meaning that it's just an either addition or subtraction depending on what it is. So this is what the graph looks like. So at x equals -3, we're at 1. At -2, we're at 0. And at -1, we're at 1. Okay? So now, so it works with h. Now let's try another one with k. So if we have f of x equals x squared plus 2, whoa, where did our thing that looked like this go? Where did that go? Well, this is called vertex form, and this is only applied when you have a horizontal transformation. It has to look like this because it has to account for the inputs. But when we have something like this, remember, you can always think of it as x plus 0 squared, and 0 squared is 0, so it's just x squared plus 2. So at this point, we realize that we have no h because it's just 0. So at this point, what do we have? We only have a vertical transformation. I showed you one with only a horizontal transformation, a shift, and I showed you one. Now I'm showing one with a vertical transformation on its own. So let's try it. So let's get our parent function graph, our points. So -1, 0, 1. This is our x values, 1, 0, 1. So remember, we have nothing here on our x values, so I'm just going to add 2 to all our y values. So what do we get? We get -1, 0, 1, and you get 3, 2, 3. And our parent function looks like this: -1, 3, 0, 2, 1, 3. So our graph looks like this: 0, 2, 1. Okay. Let's try one with a b. So if I gave you something like f of x equals 1/2 x minus 5 squared. So we know the x minus 5 squared, remember that's a horizontal, so right away we can recognize that we have an h. But what about this 1/2? This is our b. Remember the bx I showed you? So when you have a horizontal stretch, it's always the opposite. So if we have a 1/2 x squared, this means 1/2 because it's a coefficient. It's 1/2 times x. Okay, this is an x minus 5. This is different. This is a 1/2 times x. So what we're gonna do is we're gonna times our x values by 2. It's the opposite. It's a reciprocal. But remember, the b's and the a's always go before the h's and the k's because of PEMDAS. Remember PEMDAS? So since this one has a transformation which we're timesing our x values, and we have when we're adding or subtracting our y value, our x values, you have to do the ones that has multiplication first because of PEMDAS. So we're going to get our parent function points, 1, 0, 1, and we're going to times our x values by 2 first. Okay, we're going to do that. I'm getting -2. 2 times 0 is 0. 2 times 1 is 2. Our y values remain unchanged. 0, 0, 1. Now we're going to add 5 like we did last time. So what do we get? We get 5 plus -2, which is going to be 3. 5 plus 0 is 5. 5 plus 2 is 7. And we get 1, 0, 1. So now our graph, our transformed graph, looks like this: 3, 1, 4, 5, 6, 7. Looks like this. Cool. So if I gave you the same graph, but it was 2x minus 5 squared, what would we do? We do the same thing, but we times our x values by 1. I mean, by 1/2. Because it's a reciprocal, doing a reciprocal. So reciprocal means we switch the number. So reciprocal of 1/2, we flip it, is 2 over 1. Any number can be written over 1. So let's try it. So let's try f of x equals 2x minus 5 squared. So first, let's get our parent function point, 0, 1, 1, 0, 1. Let's ask ourselves, do we have any transformations? Yes, we have an h. So it's going to be a plus or minus to the x values, and we have a b. So it's going to be timesing. So since, always remember, when you have, for b's, when you have something in between, it's something greater than 0 but less than 1, meaning it's a fraction. So you have like 1/2, 1/6, 1/4. You're going to flip it. You're going to times it by 4. So if you have like f of x equals 1/4x minus 4 squared, you're going to times all your y values by 4. You're going to flip the 1/4 to 4/1. But when you have something greater than 1, you're going to flip it. So right here, we're going to flip 2/1 to 1/2. Okay? And we're going to take that 1/2 and times it by all our x values. So let's do that. So 1/2 to all our x values. So we're going to compute it. So 1/2 times -1/1 is going to be -1/2. Okay, so let's do that. So it's going to be -1/2. Okay, 1/2 times 0 is just 0. 1/2 times 1 is just 1/2. Now again, y values stay unchanged. Now we can add 5. So we're going to have to add 5 to all of these because of our h. So if we do -1/2 plus 5/1, we have to do the common denominator. So -1 plus 10/2 equals 9/2. So what I'm doing here is I'm raising my denominator that I need to the top. And remember method. So we do 2. We're going to get this common denominator I raised and divide it by each denominator. So 2 divided by 2. And the remainder I times it on top. So it's going to be by 1. Because 2 divided by 2 is 1. So I'm going to times 1 on top. 2 divided by 2 is 2. And times it on top. So that's how I got this number. So our new x value is going to be, for this one, it's going to be 9/2. And then 0 plus 5 is going to be 5. And then this one, sorry, is going to be, let's try it. So 1/2 plus 5/1. Any number can be written over 1. So this would be 1 plus 10 all over 2, which is going to be, 11/2. And our y values are the same. So this is what our graph is going to look like. It's going to be shrunk. See, 9/2 is a little more than 4. So 1, 2, 3, 4, 5. It's around here. Or less than 5 actually, but approximate. And then let's put 5 here. 5, 0, and then 11/2 would be around here. So this is how our graph would look like. So let's try one with all the transformations on them. So if you can do this, then you'll be great. So let's try this one. So f of x equals -2 x plus 1 squared minus 4. So let's get our parent function. So -1, 0, 1, 1, 0, 1. So our parent function for x squared, which we'll always do. So make sure you're familiar with those. First thing I'm going to do I have a b? No. Do I have an a? I didn't talk about a, but a doesn't matter. A, just like k, what we see, we just do. It's not like the horizontal ones are annoying. You have to always do the opposite. So for this graph in particular, first thing I'm going to do is I'm going to do the horizontal ones, which I only have 1. So I'm going to, plus 1, I'm going to minus 1 all to my x values. So I'm going to do that right here. I'm going to compute that, x and y. I'm going to do a -2. 0 minus 1 is -1. 1 minus 2 is a, 1 minus 1 is a 0. Okay? Then so that's it. That's all for my x. I don't have anything else. So right now, what I'm going to do is I'm going to times all my y values by -2. Okay, so that's what I'm going to do. So -2 times 1 is -2. -2 times 0 is 0. -2 times 1 is again -2. Then I'm going to subtract by -4, because that's our k. So our a is not our k. So do a before k and b before h. Okay, so right now I'm doing a before k because this is a and this is k. And k and a we see as we see. We just do them as we is. So it's going to be -2 minus 4 minus 6 is, -2 minus 4 is -6. -1 So then we're going to do 0 minus 4 is negative 4, and then 0, and then minus 2 minus 4 is again minus 6. This is how our graph is going to look like. So at negative 2, we're at 2, 3, 4, 5, 6. Over here at negative 1, we're at 4. And at 0, we're at negative 6. Oops, no. There we go. Okay. Let's try one more. Let's introduce a new function. So we have the parent cubic, which is the same thing but x cubed. And it looks something like this. So it looks a little something like this. So some of the parent functions, so let's plug in some points. So if we plug in a 1, so if we plug in f of 1 equals 1 cubed, it's 1 times 1 times 1. So we plug in a 1, we get a 1. If we plug in a 2, what do we get? So f of 2 equals 2 cubed, we get 2 times 2 times 2, which is 8. So these are 2 parent points that we can do. We can do any, but these are the most common ones. So let's just do one more before I end the video. Let's do f of x equals x minus 4 cubed. See, it's changed plus 2. So at this point, you should know how to do. So right away, we're going to add 4 to the left and add 2 to the right. Remember the opposite, but the k's and a's stay the same. So x, so it's going to be 5, 6, and then it's going to be 3, 10. So this is what the graph is going to look like. So at x equals 2, 3, 4, 5, 2, 3, I'm just graphing ordered pairs, 3, 6, 7, 8, 9, 10. We're going to be at, 4, 5, 6, 7, 8, 9, 10. And let me go back and let me include to my negative 1. Negative 1 cubed is negative 1. And then 1 is 1, 2 is 8. So if I add plus 4, I get a 3. So I have a 3. And if I add 2, I get a 1. So a 3, 1. So it's going to look something like this. They're a little more challenging, but I just thought I'd show, and they look pretty cool. But anyway, if you want me to do more functions, I hope this one made a little more sense from the part 1. And I hope you guys have a good day. And if you have any questions, leave them in the comments. I was able to go through almost all of them, but always remember, for the horizontal, for H and B, it's always the opposite. So anyway, have a good day, and subscribe and click that like button.